Good morning, everybody, and welcome to our session here. I am James Lee. I'm the Associate University Librarian for Academic Innovation and Associate Professor in the Medill School at Northwestern University. I'm joined here today by David Schober, our digital projects lead for our software development team. So today we're going to talk about our work leveraging generative AI tools in a search and discovery context, specifically about how these tools can be leveraged to enhance the use of digital collections. Now, what we're going to talk about today is a piece of a larger puzzle that we're implementing at Northwestern Libraries as part of our new vision implemented by our new dean, Shimo Wang. We're specifically going to address the first pillar that we've established of the new vision, transforming digital research methods. So today what we're going to describe is sort of a building block of a larger initiative called the Data Library, where we've been charged by our university leadership to become the central campus hub for data sets and AI models, locally trained AI models and research data across all of our schools. So this is one way to get that ball rolling for our campus. More broadly, Pillar 1 represents our effort to create a two-way street with our faculty, grad students, and staff across our different schools about how they want their data sets and AI models deployed to specifically investigate their research questions. So you can think of this project as sort of opening ourselves up to this conversation with faculty and students across our campus. In August, we were awarded a 2-year IMLS National Leadership Grant, and the project that we'll describe today has 3 parts. First, we iterate on our in-production semantic search system that we'll show you today. Second, we created a chat-based discovery platform that will make it easier for other libraries and institutions to adopt AI-driven search technology using their own digital collections. A core part of this work is using our existing digital collections as a test platform so that we are developing well-tested and reliable solutions. What we're developing is open source software at the end of the day. It'll be simple to set up with integration in mind, allowing users at other institutions, such as yours, to perform natural language searches across their own collections. And third, we're developing a metadata toolkit that uses AI to assist in generating and validating metadata, helping institutions describe and organize their collections more efficiently. So a very quick introduction to our project team. It's led by David Schober here, who heads the repository development team of our digital products and data curation department. I'm not going to list out all the names as of the project team, but I do want to call out something important, which I wanted to flag and take a moment on. We have a mix of metadata specialists, communication specialists, and user experience and design specialists. And what I wanted to show here is that under our new leadership, we are really committed that each vertical under all of our AULs cross-pollinate and have substantial collaboration. So this project really embodies this pulling together subject matter experts and technical experts across different departments for a common goal. For Northwestern Libraries, it was imperative to get past the breakable toy model. We wanted to own and to learn from shipping our product. We take a lot of notes in this small team from startup culture. We think about products that evolve over time and continually adapt to changes in technology. We've been working on semantic search and understanding how embeddings can apply most usefully to collections. We have 2 major AI logics that we implement here. The first is RAG, retrieval-augmented generation, that is a well-worn technology now, answering questions based on the context of results. That's focused on a bounded subset of data rather than an entire training data set. And 2 is a direction that's more experimental and new, but we're very excited about, is agent-based tools, giving large language models the ability to call a predefined set of functions. And this agent-based logic is a direction we're expanding as part of our data library direction. So we're turning around our knowledge and baking it into an installable system that lets folks at other institutions, such as yours, try this out on their own data. And to give a deep dive on this, here's David.
Thanks, James. What a great introduction. I'm very excited to be here today, by the way. So thank you all for listening to us. All right, so let's go ahead and dig right in. We have a lot to cover, and we're going to start talking a little bit about how we got to production. The development of our chat-based semantic search tool took place over the past year and a half. when ChatGPT 3.5 hit, like a lot in the industry, we asked ourselves first, what the heck is this thing? And then second, we said, how can we use this tool to help our users better discover and engage with the materials we have at the library? It became clear very quickly that augmenting our digital collection search just made sense. We started by creating a really simple proof of concept, which you see on the far left, and then worked iteratively to improve that application as quickly as we could. That early POC was a learning experience. We created semantic embeddings of all of our metadata. We spent a significant amount of time learning about vector databases, which were really just coming up at the time, and how those could integrate with more traditional search paradigms. And we developed an interface that allowed people to simply ask questions and receive answers. Early testing with users showed that this was an idea that worked and that digital collections was a great platform. It was sort of in that Goldilocks mode. It was large enough that people could ask serious questions. It's a couple 100,000 works with a few 100,000 file sets behind it, but it was small enough that we understood it and could wrap our heads around it. We weren't sort of trying to take on the entire library catalog at once. In addition, it really changed our assumptions. These early tests really changed our assumptions about how users would interact with collections in the future. We began to imagine how this could integrate into our collections by drawing up wireframes, which you see on the top, and our goal with those was to understand how to dig this tool directly into the digital collections platform rather than kind of pin it on the side. A lot of, in our experience, a lot of folks were taking these tools and putting them as sort of sidecars somewhere. And we really wanted to jump right over that hurdle and put it right inside of the system so that users would feel like it was a natural part of the system. And then finally, we refined those ideas and integrated them into the site itself. This took a little bit of time. We were able to launch just this last August to our Northwestern users. Next up here is a slide about the current state, our current production state. And what I'm going to do here is show you a user clicks on use generative AI. We didn't want it to be fancy. We didn't put a lot of things. We just wanted to describe what a user would interact with. So that's why we used language there rather than a picture. And the user is going to ask a question, in this case, about some baseball players. Just, hey, do you have any photos of baseball players? And you see immediately response comes and the system starts to answer the question based on the context of those results. So it holds the results and then tries to answer the question as best it can based on the semantics of the question as well as its understanding of the result set. Next is a significantly more complex question. Here I asked, I'm doing research on Buddhism, both modern and ancient practice. What documents might be helpful? And here you see that it is able to do a fairly broad search on Buddhism practice in a collection, and it pulls both photos from Robert Linroth, who documented ancient practice around Asia, and as well as Master Kago Roshi, who is a modern practitioner who we have his recordings. So it also took into account multiple modes and different types of practice. So here I want to talk a little bit about validating our ideas, because this is really tricky with these new systems. From the very beginning of our proof of concept, really through just last Friday, we've used every opportunity to put these systems in front of people and to develop tools to automate testing, and as well as scratch our heads about some of the philosophical questions around what testing a chat-based application really means. And I want to pause here and talk about that. Testing chat-based applications is very different than, in my experience, than testing any web-based application I've ever tested. I've been in this business for a really long time, for well over 20 years at this point. And the interesting thing about web-based applications is you have a known quantity and you put a user in front of it and you want to see how they interact with the system. What we found about chat-based systems is what we're testing is how the system responds to a user, which is not something that we've ever encountered before. So it took a whole new set of tests to understand and to sort of wrap our heads and really flip the paradigm. The one thing to understand too is that these systems don't always answer in the same way. So a user may ask the same question twice and get totally different answers. And that's to be expected. That's how these systems work. So it's really a different testing model. All right, so just a little bit more on the traditional testing side. We did traditional user tests. We put this thing in front of users and we asked them to just interact with it, and we watched them and studied it, how it worked. We also had rapid feedback loops built into the system. And we also did some anonymous collection of data. So what we collected was the question, the answer that was given, as well as the context, because all three of those are necessary to understand how the system is working. What we found from that especially during the user tests, was that people were very, very comfortable with interrogating chat-based systems, way more comfortable than we expected them to be. It was just natural. They were also expecting a lot more from these systems than we originally expected. Oops. In addition to user studies, we developed a suite of very lightweight testing tools. We built a command line tool that allows us to challenge our system with known questions, with known prompts, and return the results and compare it against a set of ground truths. The reason that was really important was so that we could rapidly develop this and change our system prompts without just sitting in front of it and trying to guess a bunch of questions and answers, right? And seeing how we wanted to get past the vibe feel of whether or not this thing was doing good. So we wanted quantitative data on that. We've been through 4 different models since we've thought about doing this, right? We've moved through all of the versions of ChatGPT as well as Claude now in our latest agent-based one. In addition, that command line tool allowed us to use an industry data set for red team testing. And I want to, again, pause here and talk about that. One of the things that we realized really quickly is we needed to do red team testing, which is to try to break the system using really terrible questions, for those of you not familiar with it. I know a lot of the folks in this room, and I know you, like I, try to hire really nice people and really smart people and really good people. Asking them to take on the persona of a terrible person and ask terrible questions is not only unfair, it's just never going to work. So we had to figure out a way to automate this, and we used an industry data set from Anthropic, which was great that they open sourced an industry data set in order to do that. It also helped us to remove ourselves psychologically from the problem, because I will say that some of these questions are very terrible. I wouldn't want to have to think about them over and over again. All right, so as we continued testing, we realized agents were the way of the future. That sort of came in the last really 6 to 9 months. What this allows us to do is to turn the system from a single turn, which is what you saw initially, to a multi-turn system. So someone can start to have a really complex conversation. They can ask for refinements. And what it allows us to do is set a predefined set of tools underneath the model, where the model, it allows that model to have access to a predefined set of tools, which allows us to get at more complex queries than we've ever been able to do in the past. It also allows us to have chat history and context refinement. All right, with that, I'm going to go ahead and talk through this video real quick. All right, so this is our new agent-based model. This one is not released yet. The first thing I do here is I ask a really general question about what I might find in the repository. And the first thing you're going to see is that the LLM does some introspection about what it has access to. It says discovering, right? It thinks about what tools it has access to. It then does a really broad search, much like the last one, and tries to answer the question as best it can based on the context of the user's question. And here it's listed a set of collections, not just individual items, and described those collections as best I can. As the user now here, I'm going to ask a follow-up question. I'm going to specifically ask about the Obama collection, and I want you to note that I use shorthand there. I just said, tell me more about the Obama collection, like a human might. And what happens next is that the agent understands that it has the ability, that it understands the fields it has access to, and searches specifically for the long-form Africa Embraces Obama collection, and returns results based on that. Then understands a little more about what's inside of that collection, because I asked what types of materials are there. It describes those types of material. Again, this is all through introspection, because we gave the agent the ability to introspect a data set, or data types. All right, next up, I'm going to ask a question about who played at the Berkeley Folk Music Festival, right? So we have a very large Berkeley Folk Music Festival, and I want to know what years they played and what types of, or who might have played there. Very simple question, sort of question someone researching the 60s might want to understand and know. Here you see it does the same, it takes the same approach. It thinks about the question, looks for Berkeley Folk Music Festival musicians, and then lists them in order by year. Now here is something brand new. Now I'm expanding the results, and I'm brought to a very traditional style, search style that we're all familiar with. And I'm filtering and faceting, but the trick here is that I'm filtering and faceting on semantic results, right? So this is the semantic set of results, and I'm able to facet there on the great blues musician, Big Mama Thornton. Anybody that doesn't know her should check her out. She's awesome. And I'm going to grab that set of results and pass them back into the conversation. And now I'm going to ask a specific question about that set of results. So I filtered the results, and I asked specifically who she played with. and when. And it understands from the context above that I likely want this in order by year and lists musicians she played with in 2 different years. Again, that's a very complex query. It would take me quite some time in our system to pull together that information. And here, because I'm a researcher and I like to look at stuff in a tabular setup, I asked it to return those results as a table rather than a list. So reformatting on the fly. This last one kind of came along for the ride with us. And what we found here is that these systems, we're using an embedding model called a Cohere multi-language embedding model. And I asked a question in Chinese. Specifically, I asked for works related works that contained elephants, images that contained elephants. And you see it understands that question. Our metadata is in English. It's able to marry the two because of the way semantic search works, return results of images that contain elephants, and then answer back in Chinese. This, again, was surprising when we first discovered it, but what it allows us to do and what it allows really anybody to do is to have a truly accessible, globally accessible site with minimal work. All right, I want to talk just briefly about Treetop now, which is our newly named semantic discovery tool for our open source discovery tool for experimentation. Our goals with it were severalfold, but first we wanted to make sure it was easily installable. We wanted to center around some collection standards that we all know and love. So we're using, we as input take IIIF collections or EAD finding aids. We may add Mark or a couple others a little bit down the road. It creates and stands up a vector database as well as embeddings and creates embeddings for you. And it's really meant to be a jumping off point for all of us to learn together. And that's really important. We did a lot of digging and learning, and we don't want everybody to have to do the same lift to get to where we're at. So this is what's installed with Treetop. So as you see on the far left, that's my input data sources. I then, with a single command, I stand up a very complex stack that includes lambdas for data manipulation and transformations, Bedrock for LLM integration, a vector store based on Postgres, an authentication so that we're not hit by bots hitting bots, which is not a very good thing, as well as an API gateway in the front. So one could take this as a stand this up and then use it in a production system, move it there if you wanted to. But the goal is really to quickly stand up a system, be able to experiment with it. It then pre-processes and chunks all of that metadata, creates embeddings for you, and stores that data. And then on the bottom, of course, is a user interacting with it. So I just have a very short video clip of this. What we've done here is taken a IIIF collection of our Fava masks, which are masks from Italian masks from Commedia dell'arte. That was a terrible pronunciation. I apologize for anybody that speaks Italian. And this took about 10 minutes to stand up with a single command. What you'll see here is that I ask what might be in here. And you see it tells me a little bit about the masks and what might be in here. But in addition, we offer debugging so that technical users can see what context was passed along so it knows where the question was, how the question was answered. And next, I'm asking specifically about whether there are any scoundrels in this collection, because scoundrels are a very big community thing. And here again, you see, yes, here are some, and explains a little bit about what those are, as well as the context available for that. So with that, I'm gonna ask a hard question here and pass it over to James.
Thanks, David. So we're really excited about this project, and it's an example of how we're using AI to interact differently with our users. And this really allows our users to explore library materials and collections differently through our browser-based interfaces. Rather than translating their voice into library speak through Boolean searches in English, it allows them to speak using their own voice and to get answers in kind. And as David noticed, the user behaviors were interesting to observe when they started entering queries in natural language. During the testing, we witnessed users expecting a very different experience than search and refine. It's not so much about answers, but rather what we witnessed was about leapfrogging from one idea to another and making connections through waves of questions, successive waves of questions. What we observed was almost AI-enabled serendipity through our collections. And what we hope is that the AI agent-based logic will help give more flexibility and more complexity to this serendipity-based inquiry. Library systems have often set the terms of how users should use their collections, or use mediated systems to guide users to specific channels of services to the collections. We hope that AI-based search systems like this opens up our collections to how a user asks questions to begin with, through their process of ideation and project and research question formation. What we hope to focus on the library itself as transforming itself, being more open and vulnerable to whatever users may be curious about. So what I hope is we're flipping the script of AI. It's not all-knowing, it's not a genie in a bottle, but rather it's opening ourselves up, making ourselves more sensitive to user questions and their open path of discovery. Zooming out, this new AI-driven vision at Northwestern, and this project is the linchpin of that, opens up our libraries to research questions and different use cases that we can't anticipate yet. But the overall goal is to become stronger partners in the research and teaching enterprise at our university. Thank you very much. And just in brief, here's a list of some of our project code and experiments and tools. And we will share these slides with you if you want to access them. And if you have any questions or comments, we'll be happy to field them now.
Can you go back one slide?
Yes, of course. There you go.
Well, thank you so much for the presentation. I wonder if you can talk a little bit more about what kind of a feedback if you have from the user end, or is there a mechanism you evaluate the results?
Sure. So we've run 3 different user tests at this point, probably encompassing at least 30 people. Our goal was to make sure that we spread it out among, researchers, some professors, as well as undergraduate students. I think our sweet spot, at least for folks that seemed really excited about it, if I was just to answer briefly, is skewing on the undergraduate side. They're very used to it, and I don't think that should be surprising, right? This is a huge shift in how people interact with systems. Folks that are sort of more further along in their research path have already baked in patterns that are going to be hard to break. And I think we witnessed this when Google sort of took over search world, right? And I think it's going to follow a similar paradigm. It's going to overwhelm us in what people start expecting. So I think we're still at the early phase of that. So I think generally speaking, folks were very excited about it. I think it depended on what their patterns were. When we put this in front of folks further along in the research phase, they started immediately jumping to Booleans with parentheses and negations, which that's not what semantic search is built to do. So it's trying to understand what that semantically means.
And to build off what David was saying, returning back to the team composition, we wanted to build a tight feedback loop based on user feedback. So along with the development team on the back end, if you remember, we have our user experience librarian, Frank Swice, is there more on the front end and thinking about the user experience and how to take that user feedback and communicate and translate it to the dev team. So that cross-functional team is important to integrating user feedback in the most useful way.
One thing that maybe was very interesting that we found is that there was an immediate expectation, and I think this is something for all of us to learn from, and maybe I would argue make us have to hurry up our processes, is there was an immediate expectation that these systems had access to everything we had access to. It was immediate. Even though we said, hey, this is our digital collections platform, there's about 200,000 objects in it, it's our distinctive collections. Immediately they wanted, especially with the agent-based model, when they could ask follow-up questions, they were asking for books related to subjects. Yeah.
So my compliments. This is a really fantastic work and a great demonstration about the motivations, the technology, and the assessment. So hats off for top-notch work. I'm wondering if you could comment a little bit about the size of the team. Did this work? Did you hit the sweet spot? Would a smaller team have been faster? Would a larger team work? And mostly what I'm thinking about the context is some of yesterday's conversations of we're all facing this challenge. Is there a way to do work in a more coordinated fashion faster than traditional library process, where in 2 to 3 years, 80% of the people get to what you've done in the last year?
Yeah.
Go ahead, David.
Sure. I'll be very opinionated about this. I think that small teams, when they have a directive and are able to focus attention, can do really good things, but the trick is you have to allow them to focus. So Tom, I think to answer that question, I think we had the right size team allowing focus. This could have really dragged out if we started to jump around and try to do too many things, because then you're starting to take cognitive load away. But in addition, when you're learning, you have those moments of like, oh my gosh, I just figured out something in the middle of the night and I want to execute on it tomorrow, especially when you're learning something brand new like this. And I think allowing a team of 5 folks, couple of front-end developers are critical. That's one thing I think a lot of libraries don't have access to, is to have front-end developers, as well as a small team of back-end developers that really know their stuff is I think a perfect size team for almost any job. You know, certainly that's how Amazon works as well. Like we've learned a lot from them in talking to them. They have the concept of 2 pizza teams, where you should never have a team larger than you can feed people with 2 pizzas, right?
And building off what David said, Tom, to answer your question, we are building on a stepwise iteration pattern of scale. So David's team began to roll with this experimentation a little over a year ago. Through the grant and through this implementation process, we invited metadata specialists, our UX specialists, our marketing specialists, subject matter experts from other departments. And then as we grow through the data library concept and some of the vision that we described, we hope to bring in more IT infrastructure folks for implementation, people from a digital scholarship, digital humanities teams that might work with faculty and subject matter experts directly. So it's more of a networked approach, I would say. It's sort of scaling through each iteration and drawing more and more team members in, but more in a distributed manner. It's not a gigantic project team, but rather this hub interacting and liaising with different folks across the library.
Hi, it's Eden from Virginia Tech. Thank you for the presentation. So I have a question. So even just like, so we all know like large language model have, they are predict, right? So they have hallucinations. So they maybe give wrong answers from users' queries. So quite your tolerance if they answered, right? But maybe part of the sentence or part of is not incorrect. But the user will not know, right? So, yeah, how do you handle that? Yeah.
If I understand, if I understand the question, it's the question is around how do we make sure that the LM doesn't hallucinate even when we're doing RAG-based approach? Like we've done some very careful and iterative prompt engineering around that. So our system prompt carefully instructs it to not answer questions that it can't answer based on the context as much as possible, or general knowledge. So with that in mind, it makes it really hard for the system to hallucinate because it follows instructions. And we publish those prompts, and as well as the iterations, they're all checked into GitHub, and anybody that's interested in how we've iterated over those. So that's the general approach that we take, and it will give up. If it doesn't know, it'll say, I can't answer the question. If you ask it about spaceships spaceships in Colorado, we don't have a collection of spaceships in Colorado, and it'll tell you that. Mm-hmm. It'll return some results just because of the way semantic search works, and then it'll look at them and say, I can't answer the question based on that.
Okay, great, thank you.
And to build off David's comment, I think, there are limitations. I think RAG is intrinsically one way to counteract this, sort of having a bounded data set of beyond the larger training data set to sort of focus the question and the range of possible answers. I think agent-based models, it's a new era of technology, and I think what we're seeing a big push in sort of agent-based research assistants that are more ambitious, beyond discovery and beyond information retrieval. They're trying to work within hypothesis generation and work alongside researchers. I think that's where it gets a little more risky. I think at this information retrieval discovery step, serendipity is okay. Having a wide net is okay. I think as the ambition scales and research assistants work alongside chemists and faculty researchers, that's when I think we need to get a little more careful. But it's a Wild West right now.
Yeah, thank you for the great presentation and also demo. I really like the part in which you sort of incorporated the filters, like part of the semantic search with the AI-driven natural language search. I was curious if you can say a little more about how you engineered them to come together in the search process. So that's one question that I have, and what the filters are based upon, whether it's a controlled vocabulary they use and things like that. And then the second question is a little bit more of a broader scope that I think this is great because it's really leveraging the sort of serendipity aspect of AI search that really helps and shines. But like you mentioned that there was the immediate reaction from the users that
does this search apply to everything the library has? And my second question in that context is also, even if they understand the scope, did you run into the expectation of comprehensiveness of the search results rather than like, how do you communicate that? We struggle that a lot where I am. So I would love to hear about that as well. Thank you.
Sure. I'll take the second one first because it's the easier. I'm not sure we've solved it yet. I think that is a challenge, right? Like, how do you tell people that what it contains without it being an odd sort of way? So I think we're still struggling with that second one. My hope is that we get to a point where we have agents that are able to expand out and ask questions of more systems. And I think we've already started experimenting with some of that. The first on just a real technical level. So we're using OpenSearch. The way that we pulled that off, it's unique. I don't think I've seen it anywhere else. So we're using OpenSearch. OpenSearch has the concept of neural search and regular keyword searching. And we do what's called a hybrid search. So we stack them on top of each other and then weight the search results first. And the great thing about OpenSearch and Elasticsearch is that you can pass that and then use your normal OpenSearch tools around it and aggregation tools. So we're just using normal OpenSearch aggregation tools and what are called post filters. So we query and then filter after the fact. Usually when you do facets, you do it in the exact opposite way. So we pass the whole query to OpenSearch again and then filter out the results we don't want. That's an awesome question. Thank you so much.
So on the topic of, the end user, so I saw like you have just questions, right, as prompts. Do you notice, let me rephrase this, how much prompt or prompt engineering is being taught to the final user to basically optimize the search, right? Because you are doing a lot in the back end in terms of connected database and things like that. Right. But since it's using generative AI, what is the role of prompt engineering in the search itself?
Do you mean from the system side or from?
No, from the end user perspective, right? Like I go and I'm trying to look, for X, right? As an end user, what is the role of prompt engineering on that particular?
Yeah. I mean, what we're seeing from an anonymous standpoint is everything from simple single word or double word searches, like baseball players, to complex queries like who played or when did Northwestern, I don't know why I'm thinking sports. I don't even follow sports. Like when did Northwestern, but because these are real searches we've seen, like when did Northwestern last beat Michigan? Do you have a film of it? Right? So questions like that. So in other words, it's an array, but people seem comfortable like hitting that use generative and just putting in 2 words and expecting an answer, which I would argue is actually very hard for the system because it doesn't have the context of what it's trying to answer. It's like, I don't know, baseball players. What do you want? Yep. Baseball players. You're not asking me anything. It's not a question. So I think agents allow us to ask, what exactly are you looking for? Here's some baseball players. We have baseball players in the collection. What would you like to know about them? So I think that's where agents will come in.
And I think a conscious choice we made was to ensure that the generative and predictive capabilities of the model were not mediated, or did not translate into a Boolean string for search, but rather directly querying the metadata, the lower level data immediately. So I think that more directly translates to user question. As the second thing is anecdotal, but I think it's a generational thing. I've seen that our undergrads and grad students are more used to this kind of search. They're more verbose, which in the past was a bad thing. They were penalized for that. But I think with chat-based queries and increasingly agent-based queries, having more language, more context helps. Whereas I think, like David was alluding to earlier, our more established investigators, our more established faculty members, they struggle. They're trying to be more efficient with their search, but that actually hinders them in the end with this kind of search. So there is a sort of mismatch between different generations we're seeing on the user end.
Sorry.
Thank you very much.